Hi guys, we're going to start Chapter 1, Tools of Geometry. This chapter basically lays the foundation for the rest of the course, the rest of the topics that we're going to study. So it's incredibly vital that you get to know and get to be familiar with these concepts that you're going to learn, and also to master the vocabulary and definitions, which I have generously provided you a Quizlet resource for the course as well. First section in geometry is section 1.1. It's called Points, Lines, and Planes. And as I said, and I'll reiterate, that these first few sections, this first chapter, gets us through the rest of the year in terms of geometry, in terms of the definitions and theorems and postulates. So points, lines, and planes, section 1.1. Unlike real-world objects, the three terms points, lines, and planes, they don't have any actual size. Okay, and those three terms, those are considered to be undefined terms. All right, undefined terms are basically terms that you can't define using known vocabulary. And you'll see that an attempted definition is on the next slide. And basically, from your experience with algebra last year, you should have some level of familiarity with points and lines. And even planes, because you've graphed points on a coordinate plane before. You've graphed lines, hopefully, in slope-intercept form or standard form. And that axis, the xy axis that you graph those points and lines on, that's actually called a coordinate plane. All right, so the concepts of these three undefined terms: a point, that's basically a location. It has neither shape nor size. If you look out into the night sky on a clear night, the stars and the planets, and even on a good night, if you see it fly over you, the International Space Station is a point in the sky. Capital letters are named, or points are named by a capital letter, and in this example here, it's point A. A line is made up of points, and it has no thickness or width, and through any 2 points there is exactly one line. So over here we have a line here, and it's named by the letters representing 2 points on the line, or a lowercase script letter. So we can name it using either capital P and capital Q, or this little lowercase script letter M here. So this line can be named as either line M, line PQ, or you could put PQ or QP together and put a line over top as shown here. Okay, I prefer to avoid naming it this way. That's just my preference. I prefer naming it one of these three ways. Okay. And the last undefined term, a plane. A plane is a flat surface made up of points that extends infinitely in all directions. There's exactly one plane through any 3 points, not on the same line. Basically, the easiest way that I can describe what a plane is, it's not a thing you fly to get from city to city. It's a geometric object. It sort of models a wall or a floor or a ceiling, or like a basketball court. Planes, they're named by a capital script letter or by the letters naming 3 points. They're all not on the same line. So in this plane here, all right, notice that it kind of looks like a four-sided object here, but know that this plane here really extends in both these directions, and it extends in these directions as well. All right, so it extends infinitely in all those directions. So we can name it by this capital script letter here, plane K, as they're showing there, or you can name it by any 3 points. In this case, we have plane BCD. You can name it plane CDB, plane DCB, whichever you choose. It's up to you. I'm fine with that. Okay. Talking more about points, lines, and planes, collinear points, those are points that lie on the same line. Coplanar points are points that lie on the same plane. And if you put the prefix non before either collinear or coplanar, that negates the original definition. So if I said that points were non-collinear, that would mean that they are points that do not lie on the same line. Or non-coplanar points are points that do not lie on the same plane. So know the difference between non-collinear, non-coplanar, and collinear and coplanar. Okay? In geometry, you're going to see that various lines or segments or planes intersect other things. So the intersection of two or more geometric figures, that's the set of points that they have in common. And definitions or defined terms, they're explained using undefined terms and or other defined terms. The first defined term in geometry is actually called space. Space is defined as a boundless three-dimensional set of all points and can contain lines and planes. Think about it. We live in space, right? We live in the universe. That's our space. Our space, as we know right now, unless I'm wrong, please correct me if I'm wrong, science teachers, our space is not bounded, all right? Our universe, our solar system, we're not bounded in the universe. And the universe contains all the stars, all the planets, all the galaxies. So that's the easiest way I can relate that to you guys. So space is, it's a three-dimensional set of all points, contains lines and planes, and it's boundless. It's never-ending. All right. So let's get to a couple of examples here, and then you'll have a little bit of work to do on your own. First off, let's look at this diagram here. All right. We're going to name a line containing point K. All right. There's multiple correct answers to this. There's actually, I think, 7 correct answers to this. So you can name it one of 7 ways. Remember, we can name lines using points, or we can name it using a lowercase script letter. All right. So we can name it literally as line A, or we can name it using the points. We could use JK, and we could put the arrow over top of it. We could even go KL, or we can go any other combination that includes K. Now let's name a plane containing L. L is a point here. We can name points or planes by 3 non-collinear points, or an uppercase script letter. So we can name this plane as being plane B, or we can name it using points. We can name it as plane. We want to contain L, right? So we could say JLM, plane JLM. JLM is their 3 non-collinear points. They lie on the same plane. And speaking of non-collinear points, 3 non-collinear points, 3 points that do not lie on the same line, we could take any combination of 2 of these, either JK and L, and M, because M is not on this line here. So let's use the same one that we used in the last example. We'll go JLM. Actually, you know what? They are points, so I actually have to put parentheses. I actually have to put commas between them. So J, L, and M. There are 3 non-collinear points. All right. If I didn't include these commas here, we would be naming a plane, or later on a possible geometric figure like a triangle. All right. Fourth example, we have a statement here given to us, and we're asked to draw this relationship. This is, an interesting thing. In geometry, you're going to be drawing things, constructing things, to help you visualize scenarios here. So line P lies in plane N. So we have a plane, and line P is on it. So let's draw that plane N. Okay. I'll draw it to the best of my ability here. So here's plane N. Again, not the greatest drawing. And it contains line L, right? Line P lies in plane N. So here's our line, and that's going to be line P. And line P contains point L. So point L is on that line P there. And that's that relationship there. Again, not the greatest drawing. I'm not, but you get the gist of that. Okay. And then last few examples here. Let's take a look at how many planes appear in this figure. Okay. Well, we know we have one plane here. We have plane T, right? But then we have to think abstractly and visualize a plane that contains this line, this line, this line, and that line. So in this diagram, while we only see plane T, we have to take into account plane ABR. Okay? So there are two planes that appear in that figure. All right? One you can see because it's drawn. The other one you have to think abstractly. And then our last example here, our points X, O, and R coplanar. Explain. X, O, and R. Are they coplanar? Well, line XR, all right, is in plane T. And since O is on line XR, then point O is technically a part of that plane. So yes, they are. Because all three of those points are on the same plane. Okay. So that's the section. Hopefully there's, let's see if there's one more example. No, there isn't. That's the section. Again, this section is the basic building block of geometry. Everything from geometry from here on out is based on the point, the line, and the plane. Okay? Later down the road, next section we'll talk about lines a little bit more. We'll talk about geometric figures. We'll talk about triangles extensively. We'll talk about other things down the road. But for right now, please do your best to master these topics here in this first section, because it is very critical to success down the road. So that's the section. The assignment is this book, these problems from the textbook, pages 8 through 11, numbers 13 through 21, 32 through 35, and 40 through 48. They're all exactly like the problems that we just did as examples. And if you have any questions, please feel free to reach out to me via Remind, the Ask Me Anything part of Google Classroom that I set up for you guys, or even email, and I'll try and get a response back to you as quickly as possible. Thank you, and thanks for watching.